Hello all. This is John Noguera. I am the Chief Technology Officer and co-founder at SigmaXL. Today's webinar, we are introducing the new features in SigmaXL version 7. The attribute measurement systems analysis, we did have binary MSA, and we've added ordinal and nominal. But what's nice now is that we have highlight for kappa and for Kendall's coefficient. So in the binary and nominal, the focus is on kappa. And for ordinal, we have highlights on Kendall's correlation. So again, green light means good agreement, yellow light means barely acceptable, and a red highlight means that there's a problem and corrective action is needed. We also, in version 7, added what's called an effectiveness report, where each appraisal is considered uniquely. That is, we do not require agreement across all trials and agreement across all appraisers, but treating each appraisal as an opportunity, how well does the measurement system do? So we call that an effectiveness report. You have your percent agreement, your confidence intervals, you have kappa scores, and especially for somebody just starting, it can be very overwhelming. And so what we provide all the information, but by putting in the yellow, green, red highlight, right away you can see how well your attribute measurement system is doing. So the coloring allows you to immediately see if a particular appraiser is a problem, or if it's a problem, against the standard agreement and so forth. So whether it's a repeatability problem or reproducibility problem, you can see that. We've added types of confidence intervals. Basically, in the templates of version 6.2, when you're doing a two-proportion test, we allow you to run an exact confidence interval or a Wilson score confidence interval. Now, the nice thing about the Wilson score is that it is a more powerful in that the confidence intervals are narrower. When you're dealing with attribute MSA, that's actually a plus because often your sample sizes are small, and you really want the most powerful tools at your disposal. What Wilson score does is it gives you an average. It's using average of 95% coverage rather than a minimum of 95% coverage. So exact is very conservative, whereas Wilson score it gives you an average of 95% confidence. And for that reason, a lot of practitioners prefer the Wilson score. So that's just something we've included as an option. If you want to match Minitab, use the exact. If you want to match jump, use the Wilson score. And I mentioned the attribute effectiveness report, where you do not have to have consistency across trials or across appraisers, and that allows for narrower confidence intervals as well. So that's treating each appraisal as a unique opportunity. The nice thing there is that you get actual type 1 or type 2 misclassification. There's no such thing as a mixed error anymore because it's either a good part being called bad or a bad part being called good. And we talked about kappa. We've added the highlights, and I'm just going to skip over these slides, just a little bit of background, how we chose our numbers. Basically, less than 0.7 is considered poor. Between 0.7 and 0.9 is acceptable, yellow. Above 0.9 is very good, green. And then for ordinal, we have the Kendall correlations, and there's two kinds. There's what's called Kendall's concordance, and Kendall's concordance is used when you have an unknown, or there is no reference standard. For example, comparing two appraisers, and Kendall's correlation is used when there is you're comparing against a known standard or a known reference. There are slight differences here. I don't want to get into all the details, but for concordance, we use less than 0.7 is red, greater than 0.9 is green, so that's actually the same as the kappa. And for correlation, it's a little bit different. Less than 0.6 is unacceptable, and greater than 0.8 is acceptable. These were based these were determined using Monte Carlo simulation to come up with the rules of thumb for Kendall's correlation. So slightly different values. Again, the important thing is if it's red, it's poor. If it's yellow, opportunity for improvement, and if it's green, it's good. One other thing we've added is we've added confidence intervals to the kappa scores as well as to the Kendall scores. So with that, let's have a look at an example. We'll start with the binary example that's in the workbook, and that is the Automotive Industry Action Group dataset, Attribute MSA AIAG. All right, so we have 3 appraisers, and we're using 0 and 1. 1 is a good part, 1 denotes a good, 0 is bad. So we're going to do measurement systems analysis, attribute MSA binary, and part, appraiser, assessed result, true standard. And one thing that we've added is the ability to specify what the good level is. And that's important because then your type 1 and type 2 information, we can tell you whether you're calling a bad part good or a good part bad. So here's the confidence interval types that I mentioned, Wilson score or exact. I'm going to stay with Wilson score. So we have added graphs with the confidence intervals. So this is the percent confidence interval within appraiser agreement. This is the each appraiser versus standard. This is the effectiveness number. And remember, effectiveness is different in that it's treating each appraisal as a unique opportunity. And then we also have confidence intervals on the kappa scores. Note the scales are different. Obviously, sense at 0 to 100. And for kappa, we only show 0 to 1. Even though kappa can be negative, we only display positive numbers because typically on an attribute MSA, you expect to have some positive agreement. You generally don't have complete disagreement. So it just makes for a nicer graphical output. So here we have our highlights. Lots of yellow. There's appraiser B does quite well against the standard. So this is a measurement system that there's opportunity for improvement. It's not a bad measurement system. There are no reds, but it's certainly a measurement system that could be improved. Again, just makes it very easy. This is a classical report, the top half, but far better to use percent effectiveness. And if it's more than 95% effectiveness, that's very good. If it's less than 85%, that's unacceptable. That's actually correlated to the kappa. So we highlight the kappa scores and make it easier in terms of overall assessment of your attribute measurement system. Now, something we've also added that is very, very useful. One is a summary table telling you that if the standard is bad, that if it's truly bad, how often did you call it bad? If it's truly good, how often did you call it good? If it was truly good, but you called it bad, how often did that occur? And if it was truly bad, how often did you call it good? So that's a summary, a misclassification summary. And what I really like here is this table for each part. If there's any discrepancy, if it's yellow, you're calling the good part bad. If it's red, you're calling the bad part good. Calling a bad part good is actually a worse error. Type 2 error is worse than type 1 in general. So if it's green, it's agreement. Right away, you can see if one appraiser is doing better than another, or our particular parts be more problematic than others. So it's just a nice, simple color coding that you can look at to supplement your traditional attribute gauge on our reporting. So that's the binary attribute MSA. Now, what I want to do is give an example with ordinal attribute MSA. So we'll go measurement systems analysis, ordinal, and so again, sample, appraiser. Here we're using a 1 to 5 scale, so it's grading parts from 1 denotes very poor quality, 2 is poor, 3 is fair, 4 is good, and 5 is very good quality. So it's an ordinal scale. We have an expert reference, so we will include that in the analysis. Again, you have your graphical outcomes. Here you have 4% agreement. Ordinal, it's very easy to get a low percent agreement score or percent effectiveness score. So what we focus in on with the yellow, green, red is the Kendall's coefficient of concordance or the Kendall's correlation coefficient. So clearly, Mo is problematic, Joe is nominal, and Sue is doing quite well. So you can, again, just see that right away. Yes, there's a lot of information here, but the color coding just helps you to hone in on where are we doing well, where are we not doing well. We also have a color code for the raw data. And here you can see Sue doing quite well, Mo has a lot of red, and Joe is kind of in between. The definition of green means that you match the expert reference. Yellow is that you were within one of the expert reference. And red is if there was a deviation of 2 or more, it's highlighted as red. So again, that's the color coding for the raw data for ordinal attribute MSA. I'm not going to give an example of nominal. That's basically just similar to binary, but extended because you have multiple levels. So if you have 3 or more unique categorical levels, then each of those are considered. So then we'll call the webinar, we'll call it a wrap, and I thank you all very much for your attention and for your attendance. The PowerPoint is available immediately, and the data sets, the examples that I've used are all in the workbook, and the data sets are available with the installation of version 7. So with that, again, thank you all very much for your participation.